right, here's an example problem, the type that you might see for your first LO in rotational motion, where we're looking at the kinematic equations for constant angular acceleration. So remember, those are the equivalent to our linear constant acceleration equations, but you just have these angular quantities. So what we're told in this problem is that the angular position of a point on the rim of a rotating wheel is described by theta equals 5 radians per second t plus 2 radians per second squared t squared. So I'd like to just take a minute and have you compare this to the general form of the equation for constant angular acceleration and see that what we're getting, some things that we're being told in this equation right here. If we compare these two, we can see that omega naught is 5 radians per second squared. We can also see that 2 radians per second squared is 1/2 the angular acceleration. So the angular acceleration in this problem is 4 radians per second squared. So I just think it's good to be able to look at those equations and pull that information out of it, whether you're going to use it or not. Okay, so for the first question, we're asked for the angular velocity of the rim of the wheel at 5 seconds. So we're given we're given theta, that equation as a function of time. We should remember that omega is the derivative of theta with respect to t. And so if we take the derivative of that expression, we're going to get 5 plus 4 radians per second squared times t. So it's going to be 5 plus 4t is going to be our expression. So that's our omega. And if we want to find the angular velocity at t equals 5 seconds, I would get 5 plus 20, and so that would be 25 radians per second. And so that's how we would do that first part. For part B, it asks how many revolutions does the wheel turn through in 10 seconds? So now I'm going back to my theta expression, 5t plus 2t squared, and I'm going to let t equals 10. So I get 5 times 10 plus 2 times 10 squared is going to give me 50 plus 200, and that's going to give me 250 radians. Now, the question is asked for revolutions, and so this is where we're going to do a conversion because we know that there's 2 pi radians in 1 revolution. And that will then allow me to find the number of revolutions, which is 39.8 revolutions. And so that's kind of a typical type of question we might run into.